Okay, your next lesson is on real numbers. And this was that really fun lesson that we had last year where we kind of drew some circles and we talked about what types of numbers were natural numbers, what types of numbers were whole numbers, integers, irrational, and rational numbers. And last year I told you too that there is something besides real numbers. There are such things as imaginary numbers, but we're saving that fun for high school. So right now we're just going to talk about real numbers. Okay, and if you're looking for this information in your textbook, my lesson 2.1 is a little bit different than the textbook's lesson 2.1. So you can actually find this information on page 46 of the textbook, and it's under section 1.8 number systems. Then if you need additional information, go there. Okay, so now we're talking about the rational numbers and what's irrational numbers. So we're going to start with the irrational side and talk about things that fit into that category. An irrational number is a number that doesn't terminate and doesn't repeat. So let's just go ahead and write that down. One, actually, and it also does not repeat. Examples of this would be numbers like pi, that is equal to 3.14159, and it keeps on going with no apparent repeating pattern. It doesn't come to an end. Another example would be the square root of 56, because if you put that into a calculator, it would come out to 7.48331477, and once again it keeps on going and we can't find a repeating pattern in it. So the only way sometimes to really tell whether or not a decimal is going to end, terminate, or to be repeating is to put it into the calculator and then see what happens. The problem with it is that on a calculator, the screen is only so big, only so many digits can fit. So sometimes you don't know for sure. It could be that if 8 digits fit on your calculator screen, that maybe in the 9th, 10th, or 11th digit, you might see a repeating pattern start to emerge. But you don't know that. So for the purposes of what we're doing in class, I'll just tell you that if you don't see a repeating pattern in the first 9 digits, there probably isn't one. So go ahead and call it an irrational number. Now, when we talk about the rational side now, it might be easiest to work from the inside out. So we're going to start with natural numbers, and we're going to put that in the middle. So let's have natural numbers be in the middle. And the natural numbers are the counting numbers, the numbers that you learned when you were little and you first started to count. And you learned, 1, 2, 3, 4, and on and on. Okay, those are your natural numbers. Outside of the natural numbers are also a part of whole numbers. So whole numbers would take all the natural numbers that you see, plus it would add 0. So we would have 0, 1, 2, 3, 4, etc. Okay, so those are whole numbers. Whole numbers then fit into the category of integers. Okay, all whole numbers are also integers. So an integer would be all of the whole numbers plus their opposites, their negatives. So you would have, let's put a dot, 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 because you'd have a lot of numbers before this, but then -4, -3, -2, -1, 0, 1, and then on and on. Okay, so there you have your integers. All right, and then the integers fit into the rational numbers, and the rational numbers now we're going to add into there, we will add fractions. So something like 22 fifths, that would be a rational number, because if I simplified that or put it into a calculator, it would be a decimal that ends, that terminates. 3.75, that would be a decimal that terminates. It could be a decimal that has a repeating pattern. 3.7 with a bar on top to show that it repeats. And of course, it can be all those things that we already mentioned inside rational numbers, like the natural numbers, the whole numbers, the integers. Okay, so that is basically the lesson. That's what this is a review from last year, so hopefully it won't be too bad. On the next slide, we're going to look at some examples. Slide, the square root of 36. Before you try to decide whether that's real, rational, irrational, an integer, a whole number, or a natural number, simplify it first. The square root of 36 is 6, okay, because 6 times 6 is 36. So simplify it first, then decide what categories it fits into. So for 6, for instance, that is definitely a natural number. That's a counting number. It is also a whole number. Okay, and if it's a whole number, it also must be an integer. And if it's an integer, it also must be rational. And of course, everything that you know about right now is real. Okay, so simplify first. So let's do it again with a fraction this time. Okay, if I have the fraction, let's say 5 over 22. Okay, what I want to do is go ahead, put it into a calculator, because I'm not sure just by looking at 5 over 22 if that would repeat or if that would terminate. So when I put it into my calculator, I find out that it's equal to 0.2272727, and then I see that the 7, 2 pattern is repeating. Okay, so another way I could rewrite this is 0.227 with the repeating bar over the 27. Okay, so since this does repeat, it is a rational number. Of course it's real, because we said they're all real right now. And it is also rational, because that's the end of today's lesson, and we'll practice in class.